Good afternoon, everyone. My name is Takiwa Smith. I'm founder and executive director of Science, Engineering, and Mathematics, Link Incorporated, and I want to welcome you to our STEM in the City workshop. The STEM in the City workshop is a program of our Math and Science Career Academy, whose goal is to introduce you to earth and environmental sciences. The reason why we specifically focus on earth and environmental sciences is because these sciences and STEM professionals that work and study in these fields impact our everyday lives, from our quality of air, quality of water, access to clean water, the soil that we're around, and how we get our food, and all of those things that are important to our everyday lives. And so it is important that we introduce you to make you aware of these fields, make you aware of the STEM all around you. But most importantly, if you are interested in, if you like to be outside, if you are interested in solving our everyday problems, then you can know about these fields, learn more about it, and meet people studying in these fields. So without further ado, I'm going to introduce Carolyn Pounders, our program coordinator, who is going to introduce today's speaker.
Thank you, Tequila. Hi, everyone. Thank you for joining us. Our speaker for today is Stephon D. Thomas, who is a native of Malcolm, Alabama. He has always had a love for soil, chemistry, and the environment. Growing up along the waterways and bayous of Alabama, one grows to appreciate nature and all the resources it has to offer. At a young age, Stephon worked with his grandmother in the gardening, planting, and harvesting crops. Working in and playing in soil gave him a love for natural resources that pushed him into a career of soil science. After graduating from Alabama A&M University with a degree in environmental soil science, he was hired as a soil scientist with the United States Department of Agriculture. Working with USDA gave Stephon the opportunity to work in over 5 states on soil related projects. USDA also gave him the opportunity to work with people of all walks of life. With over 20 years of experience in soils, Stephon is the leading expert in soil science in Atlanta and Southeastern region. He is also the CEO and president of Southern Red Dirt LLC. This company promotes soil education and consulting throughout the Southeast region. He also has volunteered and spoken at multiple STEM events over the last 10 years to educate today's youth on the importance of soil and the environment. He continues to train and mentor students. Stephon does a lecture at Fort Valley University and speaks at schools all across the southeastern region. No matter the audience, Stephon never turns down an opportunity to promote soils. Stephon still has the same joy and love for soils as he did when he was a child, playing barefoot in the mud. I'm sure a lot of us used to do that. And finally, to Stephon, the soil tells the real story. We just have to read it. And he lives in Henry County with his wife and 3 kids. So without further ado, I will hand it over to Stephon.
Wait, before you start, totally forgot to say the reason why we wanted to bring you today and the reason why you are ending our STEM in the City workshop series for this program year. Yesterday was Earth Day. And so we really wanted to have you connect on Earth Day. And then, it's about to be summer soon and people are going to get outside. And so we really wanted to highlight Earth Day. I think we forgot to do it yesterday, but just bringing you in to make that tie and connection to the earth.
Okay. Okay. Well, thank you for that beautiful introduction, and you're right. It is I like to say it's Earth Day every day. Especially for me, it's Earth Day every day. But yeah, we did have a day to celebrate the natural resources and all the things that Earth has to offer. Without the Earth, we wouldn't have a home. So that is why we celebrate the Earth, and hopefully bring more awareness on protecting Mother Earth too. So I didn't know I was going to be the last person. That's not. I don't know. I got me kind of nervous here, but
You were amazing. You're going to do amazing. And Carla and I are going to go in the background and let you do your thing.
all right. So I guess I'm going to start it off kind of how I do a lot of talks. Well, before COVID, I did a lot of talks at schools and from K through 12 through through undergrad and grad, so I've done a lot of talks. And one of the things I like to say at the beginning of all my talks is that you all are soil scientists. You may not think that you're a soil scientist, but you are a soil scientist. When you walk outside, you're looking at the soil when you walk outside. Let's say you're walking across a grassy area. The first thing you're going to think about, and especially as our children, you're going to think about how muddy it is, and if I'm going to get mud on my shoes. That is just a way of simplifying what I do. We as soil scientists, what we try to do is make interpretations about the soil. And interpretations, that's, kind of figuring out what the soil could do for us and ways of protecting the soil from erosion or protecting our wetlands. So that is kind of the main goal of a soil scientist. We take something that's complicated, that really is not complicated, but we take something complicated and simplify it to the public. And through our interpretations, let's say if you were looking at building a house and you wanted to make sure that soil could withstand the weight of that house, well, you would probably get a compaction test. So those are the things that we do. And one of the things I tell my audience is, whenever you do anything, no matter what discipline, what field you go in, you have to start from the ground up, and that's where I come in. So today, what I'm going to do, I just want to give you all a brief introduction into soil science. You may have your expectations of what soil science is. I mean, I just want to see if I could help you out, and hopefully we'll have some questions from this introduction. So what I'm going to do right now, I'm going to share a presentation with you guys. So hold on one second, and let's share. Hold on one second. I'm going to share this presentation, and let's see. All right, we're going to get the infinity mirror effect, so bear with me. All right, there we go. So, well, let's redo that. All right, so let's get started. We're going to dive into this. So what we'll do is let's share this. So today what I want to do is kind of, like I said, give you kind of a brief introduction into soils. And you're looking at the screen and you're seeing soil and rocks. What does that have to do with anything? Why would you be talking about rocks too? Well, and as we go through this lesson, we're going to talk about how rocks are what we call the parent material of soil. So soil comes from rocks, And what we'll do is we're going to go, I want to go through our soil formation, the process of forming soil. So what we'll do, let's go through. So let's talk about rocks. We live, and I don't know how many people we're going to have outside of what we call the Piedmont province, which is but we live in the Piedmont. And the Piedmont has certain types of rocks. But there's certain types of rocks all around the country. But these are your three types. You have your igneous rocks, your sedimentary rocks, and your metamorphic rocks. So igneous, at one time it was liquid lava. As you know, in Georgia, a lot of the rocks that you see, especially in the Atlanta area, are igneous rocks. Sedimentary are rocks that at one time were underwater. That's, the phrase sediment settles down, pressure, and time, and you get a sedimentary rock. Metamorphic rocks are exactly what the name says. They change. They could have either been igneous or sedimentary rock that may have gotten cooked a little bit. You put a cake in the oven. It doesn't really change that much, but it does change some of the characteristics of that dough or flour that's used to create that cake. So that's why I want to go over the rocks before we jump into soil science. So, like I said, these are the types of igneous rocks. You got granite. You have pumice, which is, these are volcanic rocks. Obsidian, which is more like your glass. So let's talk about our sedimentary. We have sandstone, limestone, gypsum, and then you have a conglomerate. So these are, and also shale. So these are some of the things that we kind of, as soil scientists, we need to know the parent material of the rocks, where these rocks, where they derive from. This tells the story. So these are your types of metamorphic, schist, gneiss. And all of these rocks are rocks. If you go outside this summer, you're going to see these rocks. You're going to, if you're in the Piedmont, you're going to see your metamorphic and igneous rocks. But if you were to go, let's say, I don't know how many people are familiar with the Lookout Mountain area, North Georgia, closer to Chattanooga. Well, those rocks are what we call sedimentary rocks, mostly sandstone, limestone, shale, siltstone, mudstone. So those are the rocks that we have. So I'm showing this to you just to kind of, I want to really focus in on this point. Rocks become soil. And that's the main reason that we study, as soil science, we study rocks. We want to know what type of soil this rock is going to derive, or where this soil derived from, what type of rock this soil derived from. So let's get into soil. So that rock, it creates soil. So here's just a definition that I tell everybody I talk to. I mean, it's our textbook definition. It is the unconsolidated or mineral organic material on the immediate surface of the earth. So really, it's the soil that's not rock. It's the material that's not rock on our earth. So, and it also serves as a medium for growing plants. That is one of the most important things that when we're talking about soil, is the ability to grow plants. Why do we want to grow plants? Well, our food, our shelter. This house is made of wood. It grows from the soil. This shirt is made of cotton. It's grown from the soil. The food that we eat comes from the soil. So it is a very important, very important feature of soil, that it can grow or support land plants. One of the things I tell a lot of my audience is that there's only 3% of the Earth's surface that can support crops. So isn't that crazy? Like, this big planet that we're on, only 3% can support crops. So, and people wonder, why do we need to protect our soil? So that's one of the things we always want to make the public aware of, that only 3% of the earth will support crops. So let's talk about my job, a soil scientist. It's pretty self-explanatory, right? It's I'm a scientist and I study soils. One of the things I guess we'll go back to that. It's not as simple as it looks, but and I want to, I want to kind of elaborate on that a little bit. We Our goal, like I said, as soil scientists, is to make something that's complicated, or that sounds complicated, simple for the public, for our farmers, for everyone and that's everybody that lives and play on top of the soil. So that's we're going to get a little bit further into soil science, but I didn't want to leave you with that. It's just as simple as the name. But so let's get into why soil is important, and this is going to kind of tie to being a soil scientist. Why did I decide to be a soil scientist? So soil grow one of the big importance, and we talked about this, is it grows food. It grows fiber. I was talking about the clothes that I'm wearing. They're made of cotton. Grows lumber. Wow, I was just talking about the house. It's made of lumber. It's made of wood. We talked about compaction. Providing a foundation for buildings. You would call a soil scientist or we would call a geotech engineer out to test. Just to make sure that soil can support the weight of a building. Disposal of waste products. Now that's a very important, that's a very important process or tool to use soils for. Most of our homes, we live in Atlanta area, so a lot of the homes are on sewer. But if you look at majority of the homes in the United States, I don't have the correct numbers, but most of them are on septic. So they're on septic tanks. So what are septic tanks? Well, the waste from your restroom, your bathroom, goes into a tank and it goes out into the soil. And the soil works very, very hard to filter that waste. And not only does it filter our organic waste, it also helps to filter and break down some of the inorganic stuff. So that's a very important process. They also provide medicines. Penicillin. It came from microorganisms in the soil. It's a lot of microorganisms. There are people that dedicate their whole career to finding cures to different diseases through the soil. They go into the Amazon rainforest to find these different cures. Also, like I said, we live and play in the soil. Like it was said earlier about me being barefooted. I love being barefooted outside in the soil. So a lot of recreation. Also, that goes back to the lumber. Soils are good for bricks. That's shelter. So also it supports wildlife. A lot of our animals live in the soil. They dig down into the soil, and that's their home. So we're in Georgia, and I wanted to just kind of touch on kind of like our so-called, I would say our state soil, which every state, majority of the states have a state soil. Like Alabama, name of their soil is Bama. And we're going to get into that too, because what I do as a soil scientist, I name and classify soils just like you classify plants. There's a common name and a Latin name for plants. You have an oak tree or a maple tree. It may be a certain something else, but Tifton is like calling a tree a oak tree. It's pretty much the simplest classification that we can give a soil. But Tifton is down in the Tifton area. It accounts for a lot of the soil here in Georgia. So that's why, and it is very productive. And that's why it is one of our state soils, our state soil. So, like I said earlier, I want to make you soil scientists. So I'm gonna teach you the things that I learned throughout my 20 years of being a soil scientist. So let's talk about a soil profile. What are we talking about when we talk about a soil profile? So this is a soil profile. This is a pit. And at the end of this presentation, I want to go over that too with you, just to show you do a little exercise, kind of to show you how we do, or how we, I'll say, describe a pit. But anyway, you have different horizons, and I don't know if you can see that. I hope you can, but that red line is separating our topsoil. So our topsoil, why is topsoil so important? First of all, it's the most productive layer in soil. Also, it helps. I mean, most of the plant gets its food from our topsoil. We also have our subsoil. This is where all our water holding capacity. This is where the plants, when they need water, when it's dry, and this is where the water's being held. This is where all our clay is located in our soil. And we're going to talk about clay, sand, silt, and clay too next. But this is where most of the water is held because of the clay. And then our parent material, mostly rock, soft rock, saprolite. That's where we're going to find a lot of our slightly unconsolidated material. So I like to say this when I do this presentation. I think of this as a slice of cake. Your most productive, or like if you're going to eat a slice of cake, the main thing you're going to be looking for is the icing, right? We like the sweetness of the icing, and it gives the cake a better flavor. Well, just think of the topsoil as being icing. Okay. So, and then our subsoil, you can't get away with just eating the icing. You have to eat the whole cake. So our subsoil and parent material, that's our cake. So that's kind of where, and we kind of got a better. This is kind of like the way we describe it as soil scientists. We have we use alphabets, ABC. We use alphabets. So our topsoil comprises of let's say the fiber material is our O horizon. Our O horizon is our humus, our organic. A lot of dead limbs, twigs, leaves, dead, I guess animals. Everything makes up our O. That's why it's, you normally have a dark horizon because it's mostly, decomposing material. Our A horizon is what we call that. It is our organic horizon, but it's mostly mineral. And when I mean mineral, I'm talking about it's not fiber. It's not like organic. It's organic, but there's more mineral in it than organic, and it's soil. So in our B, like I said, you can see the roots on this picture. You can see them going down into the B horizon. They're trying to get that good water. And then when you get to the C, you can see these little pieces of rock, which that just designates that's parent material. So this is how we look at it. And, it's simple. It's as simple as ABC. So let's talk about soil formation. We talked about that when we were talking about rocks. So let's look at Georgia. This is, the rock in Georgia, though, that's our parent material. Everything here, either it was either volcanic or underwater, or like I said, with metamorphic rocks, it got cooked just enough to change it. We start off with climate. It rains. We get a lot of rain here in Georgia. Back a couple million, this is millions of years ago. A couple millions of years ago, it's a lot of cold and hot. I mean, wetting and drying. The cooling and heating. That helps to break that rock down. We also, as humans, we're breaking down soil as we speak. But plants, trees, trees and worms and just animals, they have to break down the rock. Relief. So what do I mean by relief? You go on a steep mountain. When a rock falls off the mountain, it rolls downhill. As it rolls downhill, it breaks into pieces. That helps to make soil. We're making big rocks, small rocks. And so on. When we do that, we're making soil. Also, time, which is the most important thing. You're talking about millions of years just to create soil, and you have soil. So that's one. I think we used to give out that was a poster I remember looking at on. It takes, just to make an inch of soil, it takes 100 years just to make an inch, just to create an inch of soil. Well, I'm sorry, 500 years. I was mistaken. It takes 500 years just to create an inch of soil. But you can lose an inch of soil overnight. But it takes 500 years. So that is one of the things that I think of as a soil scientist is, hey, it takes 500 years, and if we can conserve this soil, we won't have to wait another 500 years to get soil or topsoil. So let's look at soil textures. We're going to move through this a little quicker because I want to get through some fun stuff, which this is fun too. But what is soil texture? Sand, silt, and clay. Those are our three types. This is the size of sand, which is huge compared to silt. And then compared to clay is very small. So that's what we're looking at when we're thinking of texture, how the soil feels. And we use that triangle to kind of help us to graph those points. One thing about soil, and I want to kind of talk about that too. We did talk about medicines that the soil creates. I guess the biodiversity that we have in soils. That's more. You have more living organisms in soil, and maybe in a square foot of soil than you have on. And this is micro now, small. Then you have macro organisms, which we would be considered macro, big, on the entire planet. That's how biodiverse that the soil is, and you have so many different organisms in the soil. And these are just a few. You have your shredders; they help to break down rock. They break down our organic material. And you have predators, your ants, your spiders, different things. But all these live and they eat in the soil. So, and earthworms are very important. When you're out and you see earthworm, please don't step on it, don't harm it. Earthworm they help with the aeration of the soil. They help with organic material in the soil, and that helps for us to grow more food. So these are just some examples of what soil, if treated right, this is what we can do, farming soil. This is just some examples of what could happen. And this happened. I don't know if you're familiar with the Dust Bowl. It was in the 30s or so, but the Dust Bowl where we had a long drought, and we had years of we had a lot of wind going on, so a lot of the topsoil in the Midwest blew away. So we lost a lot of topsoil. And you remember I said an inch of topsoil is 500 years. This is over, that could be lost, especially in something like this, over a night. And this is just some examples of what, the crops, they died. And this is just a modern example of soil erosion. And we're not going to dive too far into that, but these are some of the things as a soil scientist that we try to prevent, and also to educate the public on how to fix this type of stuff. So let's get into the exercise I want to go over, and then we'll get into some fun stuff. I'm going to talk a little bit about what I do and the technology I use, and so let's see if we can. I have a video that let's see. All right. So this is a video I created about, this is how we look at soil. We look at soil within a pit. We get someone to dig us a pit, and also we use an auger. But this is I think this is probably about probably a 5 foot deep pit. And this is just, we get in and we start looking. So what we're going to do in our exercise, you guys are with me now. We're here. We're getting into this hole right here. And we're going to try to describe this soil. So let's move to the next slide. So here's the soil. We're going to, actually what we'll do is we'll just bring this bad boy up. And we're going to, we're just going to do some horizonations on it, okay? So let's do some horizonations, and we'll put it in red. So looking at this soil as a soil scientist, first thing I'm going to do is like, okay, where's the topsoil? And we talked about the topsoil. It is like the icing of the cake. It is the, it is the most productive part of the soil. So what I'm going to do is, let's see. What I'm going to do is do a, hold on one second. And we're just going to let's do this in red. Let's do this in red. And we're just going to draw a line where the topsoil is located, which is supposed to be in red, but we're going to change that color. We're going to change it. So let's make that red. Let's make that red. All right, so that's one horizon. And that would be considered our A horizon. So that would be considered our A horizon. So we're going to, so the A horizon, like I showed you in the, in our presentation, the A horizon is the most productive horizon in the soil. Okay, so that's our A horizon. So now I'm looking for our B horizon, the horizon that has most of the water, right? So where is that located? So let's look. Let's see, the B horizon. So this area right here would be considered the B, but where does it stop? So I want to explain what I want to show you or tell you what I'm looking at. Is as simple as colors. The A horizon is a dark color. My B horizon is more of a red. See, you see it? It's more red. That's the clay and iron that gives it kind of like a red color. The iron is what gives it its red color. So that is our B horizon. And then below this would be our C horizon. So this is our C horizon. And this is kind of getting close into our, our, what we call our saprolite or soft rock or parent material. So after this presentation, I'm thinking that you guys can come out and work with me now. Because this is kind of what I learned in my 20 years this is soil science. So what I'm going to do now is I'm going to get back in. I want you to see my face. So let's get back into this. Hold on one second. I'm just going to stop sharing. So, that presentation was just kind of giving you a brief introduction into what we do. It gets more complicated, but it's not too complicated. I mean, you have a love for soil. You have a love for helping people. So, what I would like to do now is kind of talk about some of the careers that you can get into that tie to the soils. So I did speak about engineering. I spoke about geotech engineering, civil. I didn't say anything about civil engineering, but civil engineering. Also, like I said, a soil scientist. We have foresters that go out and grow. They go out and they grow trees. And they have to look at the soils also. You have, construction. I mean, our roads, before you put a road down, you need to know the soil type. So these are some of the careers. Soil conservationists. These are people that that help to conserve soil. They really are teachers. They teach the farmers how to grow their crops without eroding the soil away. So there are multiple careers. Like I said, you start from the ground up. Everything starts from the ground up. I'm going to show you right now. Let's look at some of the technology that we use. One of the things that I think I've on some of my presentations I've talked about is the use of drones. I use drones a lot. It helps me. The drones, they help me to see the land. It helps me to, because I want to see the big picture. Um, there are a couple other things that we can use drones for as soil scientists. We create maps. So we have to see an area photo to create a map. So we use drones for that. We can attach what we call 3D, well, what we call elevation. We can do like elevation, which is our 3D elevations. We can do that using drones. We can also, it's just a good way to see the entire, you want to see the entire area when you're mapping soils. You don't want to be stuck to one area. Also, we use GPS, and we have to know where we are out on the field. Whenever we find a new soil, we have to make sure that other people can get back to it. So we use GPS. And if you're not familiar with that, it's Global Positioning System. We use what's called GIS. And I may even just show you a quick, I may show you a quick, demonstration on GIS, which is something we use. This Geographic Information Systems. So I'm going to share something with you. I'll share my screen, and what we'll do is, let's see. Hold up 1 second. I'm going to share my screen, and I'm going to pull up Google Earth. So let's pull up Google Earth. So Google Earth, simple, mainstream software, which as soil science we use something that's called ArcGIS, or that's made by another company. But this is a good demonstration to show you as a soil scientist. The thing that I want to look at as a soil scientist is the area photo. I want to know what's going on before I get out to a site. So let's take Stone Mountain for instance. That was on the that was the picture that I had on the first page. So let's look at Stone Mountain. Okay, so let's see if we can find Stone Mountain. Should be pretty easy to find. And there it is. There's Stone Mountain. So when you look at Stone Mountain, there's Stone Mountain. There's soil on Stone Mountain. You may not even think there's soil on Stone Mountain, but there is. There's soil on Stone Mountain. So, because there's vegetation, right? It's material that can support land plants. So there's soil on Stone Mountain. But anyway, as a soil scientist, what we do is we create maps. So let's look at this area, and let's say we wanted to map it. This is something that's available to all the public. It's called the Web Soil Survey. And let's look at what's mapped on Stone Mountain. So our map. So there we go. There's Stone Mountain. So what is that? It's a soil called ashlar. So like I was telling you, we classify soils, we name them. This is a soil called ashlar. Around, you have ashlar map, and ashlar is kind of shallow to rock, which, you could go probably 20, you'll find rock before 20 inches. So these are some of the things that we use. We use a lot of technology. If I had my, this would be a nice drone. Like if I wanted an up-to-date picture of this would probably be a nice drone shot. But as you can see how Stone Mountain sticks up, you got all the soil types around it. This is kind of what we do as soil scientists. And let's see what else we got here. So you can see we mapped water. That's something we as soil scientists, we do still look at water. There's here on the surface, here on the kind of on land, water is normally used for storage and I guess drinking water storage. But we have projects or things that we do along the coast, and we look at soil under the water, because soil under the water actually it develops underwater too. Like I said about Lookout Mountain, at one time it used to be underwater. So soil is developing as we speak underwater. So there are different disciplines that are different soil scientists that look at soil underwater. So these are just some of I just wanted to show you an example of some of the technology that we use. Let me stop sharing. And let's go back. I think what I'm going to do now, I want to show you a quick video. And hopefully this video will kind of sum up kind of what we do as soil scientists. This is a video I made. I think I made this video a couple years back, more of just to show the public kind of what I wouldn't say a day in the life of a soil scientist, but kind of, maybe a day in the life of a soil scientist. So let me play this video for you, and I hope you enjoy. So let me pull that up and play that. Give me 1 second, and I'll open that up for you. And I'm just wondering, do we have any? I guess we'll do questions, and I can answer some of your questions after this video. Okay. So let me share the video with you. I'll just share my screen again. And let's see. It's going to be, hopefully it's not too loud for you. Let's see, not that one. Let's open up the other one. And it's the student video. So that's just, that kind of sums up what a day in the life of a soil scientist would be. It's not every day, but that was fun. I really enjoyed kayaking and sampling soils out in the marshland. And that was down in the Savannah area, actually. So that's kind of what we do. I got some other videos I can show you. I do want to leave some time for questions if there are any questions. Let's see. I'm going to pull up one more video. Let's see. These are, wherever I go, I video. And that's some of the technology. That ties back to some of the technology that we use. I use my iPhone a lot. I use it for everything. For GPS, for it helps me to record my data. A video, that old saying, a picture's worth 1,000 words. To me, it is worth 1,000 words. It helps me to kind of explain what I saw. So I'm gonna let me just pull up one more thing, because I know we've got a little bit of time left. My goal is not to make the water muddy. This is just an example of me. This is an example of me. I'll say describing soil. So I won't go through the whole 3 minutes, but we may zoom past it a little bit. We may go forward. So that's me that's me using my drone. Like I said, it helps me to see a better, and that's me using some 3D technology, some LiDAR, which I didn't talk much about LiDAR, or different BTX, or fragile material. And what we're looking at now is, let's get a better picture where we don't have all the sun. But this is soil. I think this is more of a shack. Minville boat outage was mapped here.
Oh, Stephon, we can't see the video.
You cannot see it? I'm gonna fix that right now.
You didn't add it to the stream.
Oh, that's what it is. Okay, sorry everybody.
No, it's fine.
Yeah, I'm glad you came in and told, because I was having a good time watching this video by myself, huh?
And we know it's a great video.
Yeah, it was. Yeah, I was quiet over here, so let me share my screen again. Sorry. All right, I'm gonna bring it up and again, but let's see. Hold up 1 second, and let's just go back a little bit.
Okay, we can see it now. Perfect.
You can see it now. Good. It happens. So I just wanted this video is just kind of the, this is we as soil scientists, we have our own different language, and I wanted to just show this video to give you kind of example of the type of language, what we use to describe soils. So, BTX, or fragile material. And what we're looking at now is, let's get a better picture where we don't have all the sun. But this is soil. I think this is more of a shack. Minville boat outage was mapped here. It's more of a shack. So when you look at it, you got your big roots. They're kind of sitting on top of this area right here, which is brittle. And you can hear how when I chop into it, it gets a little brittle and it just crumbles. You can see that it just crumbles up. This is a restriction. These roots are really stressed here. You see how stressed they look? They're kind of almost staining the along the clot, but along the. So what I'll do is I'll pause that. I just wanted to, this video is just more just to give you kind of example of what I would do out in the field. I think I'm gonna say I'm gonna stop sharing, and what we'll do is if there's any questions, we're getting kind of late in this thing. If there's any questions, I'm open to answer any questions.
Hi, Stephon.
Hello.
So we did want to hear more about the microorganisms that exist in the soil. I think at the beginning of your presentation, you mentioned that even with medicine, soil plays a part in some of its development. And I think you attributed that to the microorganisms. So yeah. Also, you even mentioned that we should, like worms, we should take care of the worms. Right, and right. Why is that?
Well, when it comes to just really, worms help to promote that organic life that's in the soil, especially the microorganisms, because worms help to kind of transfer nutrients from the surface of the soil and oxygen from the surface of the soil down into the soil, because they burrow through and they create these paths. And when it rains, a lot of the top nutrients gets to move down into the soil profile. So they're very, very important. When you have worms in your soil, that is, your plants are going to do pretty well. They also, the waste from the worms, they help to break down a lot of organic and I think even inorganic nutrients into, and they transform it into a form that the plants can kind of take up. everything's a balance in the soil. Even the microorganisms, they help the plants out. All those microorganisms, they break down certain elements or certain nutrients and make them. They break them down to a point where the plants can kind of take them up. So it is a very like balanced ecosystem down in the soil. When you take one thing out, like I said, with a balance, you're gonna, it's a, balanced scale. You're gonna lose a couple things. It affects so many things. It's almost like a butterfly effect. But when it comes to microorganisms, that's, like I said, there's so much diversity in soil when it comes to microorganisms. We have people that even just study soil microbiology. A lot of the medicines that we have, a lot of them came from soil. Just think of, like I said, penicillin. That was a modern marvel when it came to health. We were able to survive. Back before penicillin, I mean, you catch a cold or you catch a stomach virus. I mean, that was it. So we the microorganisms right now, I know there's different agencies, government, and also different organizations that they are enlisting people to bring in soils from different regions of the world to test for microorganisms that may hopefully be microorganisms that can help cure diseases. So that's just one of the things that we as soil scientists, we don't get into all. We're more of we classify soils. We're more of the ones that name them. But there are people that work in the labs all the time on just looking at microorganisms.
Very interesting. Another question that we had for you, as far as can you talk a little bit more about the projects that you've worked on and maybe how either the data that you get from your soil collection, the research that you do with analyzing what you collect and what you observe with using media. Can you talk more about how basically that science is used in these different examples that you kind of mentioned? I know one that sticks out is you talked about buildings that are built on soil and how there's a role for soil scientists in that.
So we name, as soil scientists, we name soils, and just like with plants, you have different names. You have your scientific name, and then you have a common name. So when we name a soil, that soil is just like, I'll give you an example, a soil called Cecil, which is pretty much one of the first soil names. And also it is, whenever you go outside here in the Atlanta area, if you look at something that's red, soil is red, most likely it's going to be Cecil because it's mapped there. It is a soil that's all throughout this area. But anyway, when we go out and we do research on those soils, we take the characteristics of the soil, we get all the properties, and by knowing those properties, knowing how much clay in the soil, knowing where the rock occurs, we can make what we call interpretations. These are just, making decisions about the soil and how it can be used. So I'll give you a prime example. There's down in South Georgia, there's a animal, the gopher tortoise. It's endangered. It's a gopher. It may be, I think it's endangered or it's threatened, but either way it goes, it's an endangered species. This organism, this tortoise, they like sandy soils. They like to dig down into it, and that's where they live. They make their homes in sandy soils. So by knowing that, okay, let's say a soil called Cowards or a soil called Lakeland, which is a soil down in the coastal area, coastal plain area. This is a soil that the gopher tortoise would probably prosper in. Okay. So we have a map, which, like I said, is available to the whole public. It's called the Soil Survey. You can go Google Web Soil Survey. You can pull up information about you can, through this map, you can put your address in, your home address, and you can it'll let you know the type of soil that you have in your yard. But from soil scientists going out and testing and mapping and putting these soils on a map so you could do that, let's say someone that wanted to protect the gopher tortoise, all they would have to do is just run an interp on a computer, and it'll show a map of everything that's sandy. And so in those areas, those will be the areas where they would most likely find the gopher tortoise. Mm-hmm. So that's just an example of what we can do with the data that we have. So we go out and we record all the data. We record the color, we record the way it feels, we record everything. As you can see from that video, we live and breathe soils. So by knowing that stuff, there's certain inputs that you all you need to have is, the amount of clay. You'll know the water holding capacity, or how water moves through the soil, the percolation, infiltration. You'll know all that by the amount of clay. And so all this stuff, we're able to kind of formulate and create different interps about the soil, which helps everyone throughout the nation. One of the prime examples I like to use, and this is, there's a known fact that throughout, the growth of our nation, the first thing was the railroad, right? We, having a railroad, taking it, taking it all the way to the west. And, in order to have a railroad come through your town, you had to have water and food. There's no reason that the train should stop at your town if you don't have water, because everything was steam locomotives. And then you have to have food. So you have to be able to grow food. So in order to know that, there were soil scientists that went out and test the soils, map the soils in those towns. And there's history of soil scientists being ran out of town because they gave the soil a bad rating, and the railroad ended up going into another direction. So those are, like, even from the beginning of this nation, soils have always been important. And so these are things that we, as just the common person, don't really think about. We don't know. We just think we walk on soil and it's just dirt. But a lot of decisions that are made are made from knowing soil types, and so yeah. Any other questions?
Yeah. So can you just clarify that, reiterating on what you just said, soil scientists, they study soil that's already there and been in existence for years.
Yeah.
You guys don't create soil in the lab, right?
Oh, no. We find new soil all the time. We don't create it, but we do find new soil. I've set up about 3 or 4 different what we call new series, like the Tifton and the Cecil. Sometimes we'll go out and we'll find a new soil. It may be derived from a rock that a different rock, or so there are soils that we're not creating those soils, because that comes from, like I said, that soil formation. You're talking about millions of years to make soil. But what we end up doing is our technology gets better, our understanding of soil gets better, so we're able to separate different soils out. For a prime example, I don't know if you've been down to Pine Mountain, the little White House down in that's down in the middle of Georgia, kind of. Let's see, where is that located? I don't know if you've been to Callaway Gardens. Well, Callaway Gardens, if you look up, there's a mountain chain that runs along, runs like parallel from east to west. It's called Pine Mountain. It is where Franklin Delano Roosevelt, built his White House, his little White House there. He loved Georgia, so he's from Georgia, and that's where he would go and vacation, not even vacation, but that's where he had his downtime. A lot of the decisions that were made during that time, if it war or whatever, he made those decisions down in Georgia at the little White House. That soil is a different type of soil. It's warm spring Georgia. There's warm springs that come up through the rocks, but that is a new soil that we create. I wouldn't say created, but we named. That pretty much is on that mountain. So that we just name soils. We and then by doing that, we're able to make interpretations that hopefully will help the user of those soils.
That sounds so awesome and interesting. So my last question for you is, what advice would you give to those interested in pursuing soil science?
Well, one of the big advices, one of the biggest things, I ended up getting a minor in chemistry. I did do a lot of chemistry. Because there are soil science, there are soil scientists that work in the lab, but just a love for science. I think that's the thing. Our discipline was started by a doctor, and I think it was a lawyer. These were people that they had a love for the scientific method, and they decided to go out and study like how soil, how we can grow food through soil. And this was like recently in the U.S. history here in the U.S. It's just the love for solving problems, going into, and so that's one of the things. You have a love for solving problems, and a love for the environment, knowing where you are in the environment, knowing that you can't save the world, but you can save it one piece of soil at a time, one grain of soil at a time. But I think if you love science, if you love you love being outside, you don't have to be outside, you love technology, we use a lot of technology. I think you should look into soil science. There are different universities that offer the degree. There's different programs, just like this program that we're using right now on this platform that will introduce you to natural resources. It doesn't have to be soil; it can be natural resource. It can be biology. It can be wild. You can be a wildlife biologist. Everything live and play and eat on the soil. So that's one of the So I think just talking to your counselors, maybe doing some research, doing the research on your own. That's what I had to do. And, I think that's some good advice, I guess.
For sure. I know I am definitely going to go throughout the rest of my day thinking more intentionally about the soil beneath my feet.
Well, I'm glad that it, I exposed everybody to something that I love so much.
Yes. Thank you so much, Stephon. That's why we love having you. I don't like to play in the dirt, but I get so excited just listening to your stuff. They like to sit on the sand on the beach. So there are soil scientists that study sand on the beach, right?
Yes, there are. I actually had a project where I was on the beach looking at soils, So
how did you stay focused?
I didn't. But I still was able to get the job done. We had time afterwards. I knew I was just planning my time off.
I get it. But thank you so much. As I said, we watch you into a connection of Earth Day, and hopefully as people get out and about in the summer, as their farmers markets open and we think about where we get our food, that we're more conscious as our lawn mans are out more and we're, more, or people are cutting their grass. You see, I don't cut the grass. That we really think about our soil and conservation. And if that's something that you're interested in, is pursuing a career, you know how to do it and what soil scientists do. So thank you so much. And Everyone have a great rest of your day, and we'll see you at the next SEM Link event.